Okay, question 17. So a variable x is normally distributed with a mean and a standard deviation. The probability that random variable x is less than and not including 310 is 0.975, and the probability that it's less than 307.5 is 0.86. So we want to determine the mean and standard deviation. Now, first thing I'm thinking is that I can find z-scores using the inverse normal, and I'm also thinking that I'm given two sets of information, which means I'm probably going to have to solve simultaneously. Okay, so if we're thinking about what we've got, here's my little normal distribution. Here is where 310 is, and then this space behind it, up to but not including it, that is 0.975. So that information is going to help me work out what the z-score is. So first thing I'm going to do is I'm going to state my information. P of x is up to but not including 310 is equal to 0.975. Now I'm going to go to the statistics function, distribution, normal, and we're using the inverse normal because we want to find the z-score. So our tail is going to be left, the area is going to be 0.975, the standard deviation is going to be 1, and the mean is going to be 0. That way we can find out our z-score. So we've got tail is left, area is 0.975, the standard deviation is 1, and the mean is 0. So we're going to execute that. Now remember, we're rounding to 4 decimal places. Okay, so if I round this number to 4 decimal places, this 6 makes the 9 round up, which makes that one round up, which makes it 1.96. So our first one, the z-score equals 1.96. Okay, now we're going to find the z-score of the second one. So a probability that random variable x is less than and up to 307.5, given that the area there is 0.86. So our tail again is going to be left. The area is going to be 0.86. Standard deviation is going to be 1, and the mean is going to be 0. Okay, so let's find our z-score for that. So 0.86. Okay, so now we've got that our z-score is equal to 1.0803. Okay, so we've got our two pieces of information. Now, there is a formula that you need to recall that is not given to you, and that's the formula for our z-scores. So z is equal to our score minus the mean divided by the standard deviation. So I'm going to input that for our first one. We'll call it... okay, we'll just do it. Okay, I'm not labeling today. Not good at it. Okay, so 1.96 is equal to our score, which in this case is 310, minus the mean over the standard deviation. Now, I'm going to do the same thing for the other equation. So 1.0803 is equal to 307.5 minus the mean over the standard deviation. Now, we are going to rearrange this. So I'm going to flippity-flop these two. What's on the bottom must come to the top. Okay, and that's going to give me standard deviation is equal to 310 minus the mean over 1.96, and standard deviation is equal to 307.5 minus the mean over 1.0803. Okay, so next thing we need to do, what this is really saying is these things are simultaneous. If I graphed it, there is a point where these two functions touch. So what I'm looking for is the value for the mean that would make these two equations equal to the same thing. So now I'm going to we'll call this U1, U2, we're going to make them equal to each other. So 310 minus U over 1.96 is equal to 307.5 minus u over 1.0803. Now, in my calculator, I'm going to use solve n to do this. So that, it gives me an answer straight away. Now, I'm not going to put this in the calculator with you because I've already done this and we've done a fair bit of solve n. So the answer you should get for that one is that the mean is equal to 304.43. And then I'm going to put that back into one of these equations to work out standard deviation. So standard deviation, choosing this one, is going to be 310 minus 304.43 divided by 1.96, which is going to give me a score of 2.84 when you put it in the calculator. So there we go. That is my standard deviation and that is my mean.